Okay, so the first huge idea was recursion. And it's an idea that allows tiny programs to have big effects. And it also, by the way, helps kids in their understanding of mathematics, because the idea of recursive structures comes up time and again mathematically. I guess most obviously when you do mathematical induction. So they're very linked ideas. But the next idea is higher order functions. And to introduce this, the first thing I'm going to do is look at this block 3 plus 4 that's on the screen. And I'm going to click it. And guess what? The answer is 7. 3 plus 4 is 7. OK? And now what I'm going to do is scroll down the operators menu and pull out this thing called the block. And I'm going to put 3 plus 4 in it. And I'm going to ask for the value of the 3 plus 4 block. And you see now that that is not 7. It's the 3 plus 4 block. OK, so this is like those scripts that had hex and star and square in the V program. We have a piece of code, namely the 3 plus 4 block, with this gray border around it that's supposed to remind you, I'm using this as a value, as a datum, rather than as something to do right now. So one of the things that I always tell students is almost everybody seems to have built into their brains a very sharp distinction between things and actions. So every human language has nouns and verbs, and we just think differently about them. And in the programming world, it's program and data. Right? Program is stuff like functions, procedures, statements, whatever in your favorite language, blocks and Scratch. And data is stuff like numbers and character strings and stuff like that, right? And what we're trying to do here is break down that wall so that something can be program and data at the same time. And this has traditionally been a pretty hard idea for people to wrap their minds around, except for a tiny fraction of the population who are the born mathematicians who just get it, you know, that's obvious, now what? There are a few people like that, but most of us are not like that. It takes some struggle. And so I'm really very proud of this visual representation of program as data. I think when you look at that picture that we're looking at right now, it's really hard not to get the idea that there's a difference between 7 and the 3 plus 4 block, right? And what we're looking at, Susie would like to enter the room.
Oh, yeah, that's me.
That's you. Sure. But I don't have something that says yes or no to click on. OK. So that's it. That's program as data. That's the whole idea. Except we haven't talked about what to do with it, what it's good for. So what I'm going to do right now is I'm going to go to File. No, I'm not. I'm going to go to New Sprite from File, the middle New Sprite button. And I'm going to go to Costumes. And the very last thing that's sort of invisible says Tool Sprite in its name. I clicked Costumes over here. And here's Tool Sprite. I'm going to click on Tool Sprite and say OK. And it's going to take a little while to get it in.
This is new, Tool Sprite?
What?
This is new.
This is BYOB. We're not using Scratch.
This is definitely BYOB. It's not that new. It's since 3.0.
Oh, yeah, OK. Yeah, nah, yeah, all right.
Okay, so then I get this ugly picture that says import me, then delete the sprite to keep the toolbox in your project. So I'm going to do that. Well, before I do, let me show you that the tool sprite comes with a whole lot of commenting. So a useful thing to do that we're not going to do right this minute is just scroll through this, look at all the examples, read the comments to familiarize yourself with what's in the tool sprite. But for now, I'm going to delete it. I'm going to come down here to the sprite corral. I'm going to, sorry? Yes?
How do you write your own comments?
How do you write your own comments? If you have the mouse on the background of the scripting area and command click or right click or whatever, add comment is one of the choices. And that makes a comment block. And then you can drag the comment block like this, and it will attach itself to whatever block you drag it onto. Okay? Okay. So now I'm going to delete the whole tool sprite. I'm going to click on tool sprite down here, command click, delete.
So how do you import it first?
How did I import it? I went to this middle new sprite button.
When it says import me, then delete,
Yeah,
once you've loaded it, like that's the importing?
yeah, that's it.
Oh, I thought
Yeah, once you have it, you just bring it in and then you delete it. And now, if you look, for example, in the operators menu, you will see a bazillion new blocks. Bazillions of new blocks, including Pig Latin. Yeah.
Now, this wasn't this, when, I remember when we opened up, I forget when we opened up something that was already there. We opened up a file in the past, and I worked with it last year.
You can import the project tools, but the easiest way to do it is choose new sprite from file, tool sprite, and then delete the sprite. Okay?
So it gives you these extra.
So all of these, hello class, all of these tool sprites, the first thing for you to remember about them is that each one of these is written in BYOB. So we could edit any one of these. I could say all but the last word of, just for example. I can say edit. And here's the definition of all but the last word of, which I'm not actually interested in looking at right now. But just to show you that they really are all just BYOB programs. So there's,
Just click on it, I got a little speech bubble next to it.
yes, you have to control click on it or command click on it to get the menu. So what I'd like you to do now is go to the variables menu and scroll down toward the bottom of that. There's this entire screen full of new blocks that you haven't seen before. And we're going to focus right now on 3 of these. There's one called map, there's one called keep, and there's one called combine. Okay, so I'm just picking those up to put in my scripting area. And now I'm going to grab this list block, not make a list, but the one that has list as its name. And there are these arrowheads at the end. If you click on the right arrowhead, it gives you some more input slots. So you can make a list however big you want. And I'm going to make a list of numbers. You can use any numbers you want. Okay?
Wait a couple seconds, everybody catch up.
Yeah, okay.
You okay?
So here's my list. Oh, let me actually just click on this and show you what it, hello? TV land? You can't see anything. Oh no. Oh boy, that's really slow. Let's try this. Did that help any?
Yeah, just moved it.
Okay, great. Awesome. Awesome. Yeah. Yeah, so what I did was just jiggle the screen, I mean the window in the screen. Okay, so guys, the value of this list block is a list, right? When I call the list block, I get a list of whatever elements I had put in. Okay? So now, I'm going to take this thing that says the 3 plus 4 block, and I'm going to change it a little bit by just deleting the 3. So now we have the nothing plus 4 block. And the value of that, if I just click on it, is the nothing plus 4 block. Okay? So now I'm going to take that and make it the first input to map. Oh, I'm also going to switch to tiny screens so we have a lot of scripting area room. And I'm going to grab my list and put it in the list input of map. So now here's what my map block looks like. It takes 2 inputs. Map takes 2 inputs. The first input is a block, which is to say a function. And the second input is a list. So this is our first example of a higher order function, which is a function of functions. And now let's click on this and see what answer we get. And I get a list of 3 values, but they're not the values 7, 8, 1. They're, hello, ding?
Yeah, mine.
Well, they're,
Block thing isn't sitting right.
I'll help him. I'll help him.
okay.
Oh, I didn't put 7, 8, 1.
Oh, does your block thing look like this?
Data in the map.
What?
I can't get mine to sit right like yours is sitting.
Does yours look like this? Is that the problem?
This in here.
So it's like
Is that what?
But I can't get list to sit on.
Okay.
in the data of the
Yeah, so what you need to do is let go when you see the white halo. And the list, oh, here's another thing. Ladies and gentlemen, could I have me talking? When you want to put blocks inside blocks, this is a deficiency of visual programming, I guess. It's always a good idea to grab the left end of the block. And then it's much easier to put it down where you want it. Okay, so I run this, and what do I get? I get the list 7 plus 4, 8 plus 4, and 1 plus 4. Let's see. All right, I'm going to walk around the room for a second. What?
The map is really just saying add
This is
this to,
solid.
add this to this.
No, the map is saying whatever function you call. Oh, wait. Oh, yeah.
Why is mine gray and yours
Yeah.
solid green?
So if you're seeing gray, you have to let go as soon as you see the white halo.
It wasn't all the way in?
It was too far in.
Too far in.
Yeah.
Interesting.
Don't click it there.
No. It's,
Don't click there.
yeah. Okay.
Oh.
Okay.
Over here to the left-hand side. We have this back. Now you can click anywhere that's not where you see the parameter.
Okay. So people are having some trouble about dragging the right thing to the right place. So let me wait a minute for everybody to catch up in the right manner. You should see no gray border around the block. And you should see the block as the first input to map and the list as the second input to map.
What does he mean by over? Is that a division?
Oh, no, it's not over like divide. Map a function over a list is math speak for call this function for each item in the list and make a list of the results.
And so basically, because you have the blank plus, it's putting the list in the blank space.
So it's putting an element of the list in the blank
If
space.
you didn't have a blank space and you just have 4, would it do anything? Like if you said map 4 over.
You can't just map 4. There's no way to say that really, but
20 miles adding, but
it's adding because it's a plus block. Yeah.
makes sense now.
Okay.
So if you have time, it would multiply.
That's right. But another thing I can do, folks, let's look at this. what if I delete the 4 too? So I have the blank plus blank block. I get 14, 16, 2. So it's 7 plus 7, 8 plus 8, and 1 plus 1.
So in essence, whatever parameter you do not have in there, it'll put that value in that.
Yeah, so wherever there's a blank space, we fill it with an item from the list. Okay? Where this notation comes from is, anybody went through the new math? Either a teacher or a kid? Just Eugene. They're too young, okay. So long ago, before most of us were born, I guess, people wanted to teach real math to children instead of teaching them just how to add and subtract and multiply and divide, which was very, very well-intentioned and good and didn't work out perfectly for reasons that are irrelevant to this conversation. But one of the things that came out of that was an interesting piece of research on children's thinking. By children now, I'm talking about, say, 3rd, 4th, 5th graders. No, even younger than that, 2nd graders, 1st graders sometimes. If you show a really young kid x plus 4 equals 7, the kid will have no idea what you're talking about. You say, what's x? What do you mean, what's x? X is x. But if you show that same kid square plus 4 equals 7, what goes in the square? The kid will say 3. So it makes a huge difference how you present things. And these empty slots here are the legacy of the box plus 3 notation. Because kids just get filling in blanks like that. So that's the way to think about this and how to show it to kids. Okay, so this could be any function at all. We can change this to multiply if you want, and now it's going to be the squares of the numbers.
Wait, how did you change the operator?
I control-clicked on the plus sign. Yeah. Okay, so any questions about what map does?
It's interesting to put a number in both spots. Like put
Yeah.
2 times 2 or something.
Okay, sure, let's put 2 times 2 to see what it does. And we get the list 444.
So it won't call it.
It did.
Does it have value?
It computed the value of 2 times 2 for 7, and then 2 times 2 for 8, and then 2 times 2 for 1. Yes, Baker, what?
Do this for them.
Oh, jiggle the, yeah, sorry, I forgot. So here we are doing the 2 plus 2 block. What? Oh no, wait, hang on, I'll try again. How's that? Okay, 2 plus 2 block. Now the thing that I can't do for you guys is jiggle it after I click on the block, because this little balloon shows up when I click on it, and if I move away to jiggle the screen, it goes away. So you have to do your own clicking on the block.
Add one other thing. Because we haven't done this yet. In the operator, the 2 times 2 operator, to the second part, add another operator.
Okay, sure.
Leave one side of it blank and see what happens.
Yeah, all right. So Eugene wants me to give you a more complicated function. So let's do blank times 3 plus 2.
Yeah. Blank times 3 times 2.
Times 2. Whoops. Blank times 3. I wanted plus 2. Here you go. Blank times 3 plus 2. Jiggle the screen. Hope you guys can see this. Click the thing. No, I don't think so. And so 7 times 3 is 21 plus 2 is 23. 8 times 3 is 24 plus 2 is 26. And 1 times 3 is, I forget, 3 plus 2 is 5. Okay? So whatever function you give, it applies it to the list. Okay.
In the
Every-
blank, in the blank spot.
Yeah, it puts whatever value you give in however many blanks you give it. Okay, that's map. Now let's talk about, oops, no. Now I'm going to show you keep. So here's the keep block, and I have my same list. And this keep block has a hexagonal slot in it. And that means the kind of function that it wants is a predicate function, something that's hexagonal, reports true and false. I still want to use the block, but now I'm going to use it on, oh, I don't know. Is blank greater than 6, okay? So jiggle the screen, look down here, keep items such that, notice that the block has turned hexagonal, by the way. It's a cute little trick that it does, because I put a hexagonal block inside it. So again, remember, if I just do blank greater than 6 by itself, the value of that is the word false, right? So what I'm looking for is the function, oops, jiggle. The function, is this greater than 6? Is whatever the argument is greater than 6? So the value of the block is the function that I want, which is a predicate function, one that returns true or false. So I stick that into keep, and now I jiggle the screen again. I hope this works. And I click it, and I get the list 7, 8. Okay? So it's selected a subset of the list, namely those elements for which the predicate function reports true. Okay? Questions about keep? Great.
So keep actually discards items that don't
Okay,
meet.
so the question is, keep discards items. Yes, but don't form the picture in your mind that it's changing the input list. The input list is still what it is. It's making a new list that's a subset of the input list. Yeah,
Criteria.
it meets the criteria. Okay? And finally, I'm going to make another copy of my list, and I'm going to take the plus block, okay, and stick that in here. All right, and jiggle the screen. I'm going to say, okay, now this is a little tricky. Everybody's got to listen. Combine doesn't expect a 1-input function. It expects a 2-input function. So there has to be 2 blanks. And they don't mean put the same thing in each blank. So what combine does is it says, okay, let me take 7 as the starting value. That's the first thing in the list. And then let me take 8 and use 7 and 8 as the arguments to this plus function. So that gives me 15. And then we go on to the next one, which is 1. And I say, okay, let me take 15 and 1 and put those together and get 16. Okay? And Dan is kind of frowning at me because he wants me to tell you that it really goes right to left, not left to right. But everybody except Dan only uses associative functions anyway as the combiner.
No, you convinced me.
Okay.
Because I do MapReduce.
Yeah, okay.
You do MapReduce,
Yeah,
you
right.
don't know what the order of this
Right.
thing
Okay. So it doesn't. So basically, unlike map and keep, I can tell you right now every single function you're ever going to use with combine. They are plus, times, and join, basically. Join means stick two pieces of text together. Because what you want is accumulators, things that take in a bunch of values and bring them into one value. It has to be a function that's associative, and it actually makes the most sense if it's also commutative, although that's not true of join. But associative is the really key thing. And so you're never going to use subtraction as the combiner function, because subtraction is not associative. That means A minus B minus C is a different thing from A minus B minus C. And so with non-associative functions, you have to start worrying about what the sequence of events is, what order things happen in. And you don't want to do that. So you're only going to use associative functions in here. So let me jiggle my screen once more and make sure everybody's with us. Yeah.
Addition, multiplication, and multiplication.
Join is the other one. There's a join block that,
Join and join words.
and there's join words, which is in the tool block, yeah. So I'm going to click this, and I get 16. So the answer this time is not a list, it's just the number 16.
So if you have 7, 8, 2, it'd be
17, yeah, right. Okay, so is everybody?
And an or as well.
Oh, that's true. And or are possible combiners, too.
So raise your hand down at the bottom.
Okay, yes, Baker. Ah, okay. So what you did wrong is when you pull the block into the combine block, as soon as he's not seeing anymore. As soon as you see this white halo, you let go. If you keep going too far and get a gray border around the block, then you're in trouble. We'll talk about gray borders in just a minute. Okay? And then you should get 16.
Let me just go on record just to add my little 2 cents to that.
Okay.
Brian always says that you only use, and or and join and plus and multiply. I believe combine should be taught in a more general way when you get to more advanced things. So I like the idea of being able to have two lists and being able to say sort a list, take a list that's unsorted and using combine with a very clever thing to sort that. And so then you'd have a little bit more complicated guy that takes two guys that are sorted and merges them together and does something interesting like that. So I think you have ideas of what if you had records? So I have CDs and I wanted to merge them all to be one. So you can combine on lots of things. I think
Yeah, you can combine lots of things. I tend not to.
Well, only advanced stuff is what I say.
I get headaches reading code like that. This is a 10-year-long argument between us already.
That's okay. This course is
We're different folks for different strokes. So, yeah, like that. Only commutative.
Well, but you won the associative commutative argument.
Yeah. Okay. All right. So that's map, keep, and combine. So I'm going to sit down because I'm an old man for a minute. But I'll sit on the thing so that I'm more in the screen. Map, keep, and combine are by far the three most useful higher order functions. And if what your kids take away is just how to use map, keep, and combine, that's already going to be a big win. Because what these functions let you do is think, for example, about a vector, the mathematical vector. Okay? Well, a vector is just a list of numbers. So if you want to do something like add vectors or multiply vectors or do a vector times a scalar or any of the stuff that people do, or you have matrices, which are lists of numbers, and you want to multiply them, this lets you do that kind of operation sort of all at once, conceptually all at once. Instead of having to say, well, let me have an index variable I that goes from 1 to the length of the blah, 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 and item number I plus item number J, blah, blah, blah. Instead of thinking like that, you can just say, do something to this whole vector at once. And it really, really is a great way to learn to think about handling complicated data. So just map, keep, and combine, that's already a lot to learn. But it's not like these are the only higher order functions there are in the world. This is the problem that Guido von what's-his-name has, the guy who invented Python. What? Rossum. It's Gollum or something. That was a joke. He says, well, we don't have to have higher order functions because the only thing you ever use them for is map, keep, and combine, and we can have 3 different special case kludges to handle that. So there's this big argument in the Python world between people who understand higher order functions and the guy in charge of the language who doesn't understand higher order functions. You can follow the Python news feeds and you'll see that. So you can write higher order functions for anything. I'll show you some more higher order functions in a bit. Well, no, I'll show you another higher order function right now. Here we go. New higher order function. Man, click.
So this is a wacky
Oops.
question. What's the distinction between lower and higher?
Oh, a zero order function is a function of something that isn't functions, like numbers. So plus is a zero order function. A first order function is a function of zero order functions. And a second order function is, am I off by 1? Yeah, no, I think I'm off by 1. A first order function is a function of numbers. And a second order function is a function of first order functions. And a third order function is a function of second order functions and so on. So higher order means anything that's not just functions of numbers or text. Okay, functions of functions. Okay, make a block, if I can do this. Control reporter, and I'm going to call this compose. Okay, so you guys in TV land, I'm making a control menu reporter called compose, and it's going to take 2 inputs. So create input name F. And let me show you something else here, by the way. So far, I've kind of slid over this. But when you make an input name, you can do it in the simple way that I've been doing it. Or, if you want, you can say what kind of input it is by clicking on the arrowhead and getting this long menu. So I'm going to say F is a reporter. I click reporter, so I'm going to get this shape input slot. There's the arrowhead on the very right after where it says input name. Oh, time to wiggle, yeah. So here's F. Oh, let me wiggle after I start G. So here's G. Wiggle, and there's this arrowhead right here, which I'm about to click on. And then I'm going to wiggle again. And we get this long input name dialog. And down in the middle of it, it says reporter. I'm going to click on that, and then I'm going to wiggle again. Here we are clicking on reporter, and now I'm going to say OK. So now I have what? Oh, right, it already exists, so I don't have to make it. I can just show it to you because I loaded the tool sprite. I forgot that I loaded the tool sprite. Don't bother calling it anything. Just go to your tool sprite. I'm going to delete. Oops. Delete. Yeah, just say cancel. And you should find it already in the tool sprite and just edit it. And wiggle.
Hey, do me a favor, go through that one more time from the beginning. Because we didn't see the error. And where are you right-clicking and getting the block editor?
Anywhere in the script editor on a Mac, if you Apple click, you get this little teeny menu of it. So you got to make a block.
Not anywhere in the script background. It has to be on the gray part. Tony Diaz would like to enter the room. Sure. Enter the room. Okay.
So this is, hey, can you slow down? I'm
Sure.
too slow back.
That's okay. You wanted to cancel this one because when I say that there's already one there, the way you edit it plus the
Yeah, I'm actually going to do this way.
Scroll this down to the bottom. You see the compose. Although it's actually there. Let's go. So you want to drag that out.
Now I'm going to just swoop this in like this. So you don't have to do this. You guys, listen up, everybody. You don't have to learn how to make this right now because it's already made, because we loaded the tool sprite in, which I forgot. So just go to the control menu and find compose and command click it and say edit. And what you'll see is something sort of like this, except it used to have the report down in here, and I moved it up to report blocks so that it's all together. So compose is a higher order function. Its arguments are functions. Both arguments are functions, f and g. And this reports the composition of those functions. So what does it mean to compose two functions, f and g? It's the function f of g of x. Right? You make a new function that's the composition of the two functions you started with. And composition of functions is, you know, something you learn in Algebra 1, I think. 2, Algebra 2? Okay, Algebra 2. I went to a class for smart kids, I guess.
We only had one algebra in my day.
Yeah. Okay, so Algebra 2. So composition of functions. And what we want is the function that takes some argument, typically they call it x, and does f of g of the argument. So I am reporting a function. So report the block. That's how you say that the value returned by compose is also a function. So this is a really cool higher order function because both of its inputs are functions and its output is also a function. So it reports the block that does what? Call f with the input, call g with the input empty slot. So this is like h of x equals f of g of x, sort of, is what this is saying.
When you say report, that's just report out to anybody?
It says that's the value that's, if I
For that.
click on compose, that's what will be in the little balloon.
Call it return value.
Return value, yeah. Yeah, oh, jiggle, sorry. Thought I did. Oh, that's not, how's that? Does that count as a jiggle?
That work? Yeah. That works. That actually works.
Yeah, maybe, okay, well, here. I guess you're okay. All right, yeah, I haven't changed anything in a while. I'm still looking at this amazingly beautiful thing. This is not something that I would show kids the first day we're talking about higher order functions. You guys have to remember as we do this that I'm trying to compress into a day things that you're really going to do over the course of the next 7 weeks. To try to point out the high points of what you're learning. And this is definitely a high point. This is, you know, if you walk away understanding this, you've really gotten not only some serious computer science, but some serious mathematics too. Now, before you really understand it, I'm going to have to show you an example of how compose is used. So let me go ahead and do that for a moment. So we're going to lose the definition for just a second. And I'm going to put the definition down here. Folks out in TV land, I'll jiggle in just a moment. Put that down here. Take this here. Okay, I'm going to compose the block times with the block plus 3. Jiggle. What?
Put one argument at a time. Don't use this square thing.
Why?
It's not as clean.
We've already been through this.
Did they say
Yeah, I mean, just relax. It's way clean. It's beautiful. The block is down in the operators menu. It's underneath the first horizontal bar.
once you have a block there, you can just like copy it.
Sorry? Yeah, you can duplicate, yeah. Yeah. So this compose that we're looking at right here is the function of x that's x plus 3 parentheses squared. Because g is the x plus 3 function. X maps to x plus 3. And then we're composing f with that, and f is the square function. So we take x plus 3 and we square it. And that gives me a new function. And now if I just click on this, and again, I can't do it and also jiggle. It's not very edifying. It's the block call f with inputs, call g with inputs blank. It's the same thing you saw in the definition. Okay? But if you go to the control menu and find the call reporter, which looks like this, and it's down here, and I'm going to call this function, and then I'm going to click on this right arrowhead on the call block at the end, and I get with inputs, and now I'm going to put in a number, like let's say, oops.
How did you get the call to make the little surrounding darker yellow?
What? How did I get the compose into the call? I dragged compose in toward this oval. I had already made the compose, and then I put it in the call. Okay, class, before you click on it, what number am I going to get? From this. No, you're doing it backwards. Yep, we got a 64 from TV Land. We apply the function g to 5. So blank plus 3 applied to 5 is 8. And then we apply the times yourself function to that, and we get 64.
How did we know the ordering for that? Because visually it's backwards.
No, it's not. It's because you do f of value, argument,
F of argument.
right? And so what we're doing f of is g of, so, right?
If we wrote it with parentheses, it would be that.
X plus 3 in parentheses squared,
Got it.
right? Hi. Were you saying something that I missed? Go ahead. All fixed. All right. Good. Okay, so.
5 plus 3 gets out first?
F of g of x. G of x is plus 3.
So the great thing about this is that I was able to make the compose function as a thing in itself. I could give that function a name. I could make a variable whose value is that function. And then just call that function by name. So compose, you don't have to give it the number that's sort of the ultimate argument that you're going to use. You just take two functions, and it returns a new function. And if you can think at that level of abstraction, where functions are manipulable things, it's really beautiful. So let me show you one more example. In the tools thing, let me get rid of this. In the tools thingy, you will find this block. I'll get rid of all these other things for the moment. Oops. So this is a for block, jiggle. For I equals 1, step 1 until 10. Here, big stage. And we can nest these. So I'm going to say for I equals 1, step 1 until 4, so it doesn't take too long. And for I equals 1, no, stop. Yeah, right, I'm getting there. For J, no, I'm going to call it K, actually, because it's a more visible difference. 1 step 3 until 10, and then I'm going to say for, no, stop. Say for 1 second. The for block is in control. It's down in the bottom half of control.
Do I have to import
The tool sprite, yes.
tool sprite? So if I make a new one, then I have to do that.
Yeah. And I'm going to take join words out of the tool sprite also. I'm going to put this in here. I'm going to say join words I. Okay, there we go.
The stuff's just saying it's like an increment.
Yeah. Okay, gang. Here, jiggle, jiggle. Okay, so guys, watch the screen. Watch what happens when I run this on the stage. We get 1, 1, 1, 4, 1, 7, 1, 10, 2, 1, 2, 4, 2, 7, 2, 10, 3, 1, 3, 4, 3, 7, 3, 10, 4, 1, 4, 4, 4, 7, 4, 10, stop. Okay? So that's not so amazing. Any programming language can do that. But what's amazing is that the for block was actually written in BYOB. It's not something that is built into the language. It's something that you can write in the language. And the code has one slight complexity to it, which is that if the step is negative, then the end test has to be different from if the step is positive. So if you're stepping downward, it's different from stepping upward. But leaving aside all of that, direct your entire attention, or let me jiggle the screen. Direct your entire attention to the block where my cursor is. It says run action. Action is the thing that you put, the name for the thing that you put inside the C-shaped slot. That thing that you put inside the C-shaped slot, Scratch has lots of these C-shaped blocks, right? Like forever and repeat and if and so on. And kids who use those don't think about higher order functions when they're using it. But in fact, the stuff you put inside that C-shaped slot is a script treated as a thing. So it actually is a higher order procedure. All those C-shaped blocks are higher order procedures because they take scripts as inputs. And here we've given the C-shaped script the name action. And so I can say run action. And that does it. Now there's a lot of details that I'm hand-waving over. Like how is it that I could nest 2 of these and have 2 different variable names for the 2 different, how did that all work? I'm finessing all that for now. I don't want to talk about it. All I want to talk about is the fact that it says run in there. You've seen run before, namely in the V program, where it said run item any of ends. Remember that? So run says take some script and run it. You can give those scripts inputs, so they can have blanks in them, and we can fill them with inputs, the same as we did for map and so on. But the main thing is, a kid could write this. A kid could for sure write the version of for that only steps forward by 1 each time. So leaving out a lot of details, you know, for I equals 1 to 10, always moving in the positive direction. That's a really, really easy script to write. Okay? This is a little more complicated, but only a little bit. Okay, so that's the for block. And again, lots of programming languages have something like a for block built in, we don't have to have it built in because we have something better built in. We have the ability to encapsulate blocks and scripts and treat them as data. And once you have that, you can build any control structure you want. So this is the big magic idea of higher order functions. Okay? So now let me show you something that you need to see, which is if I,
15 minutes.
okay. Oh, Command Tab. Make a new. I don't want Adobe Connect. I want.
It'll get better, but it's a sketch.
Yeah.
That's a sketch.
There we go. Command Tab. I'm going to the BYOB website. And when I get to the BYOB, I'm not even going to try to show this to TV Land because they're only watching the BYOB screen and it's too much trouble. But you guys can go to byob.berkeley.edu yourself, and practically the first thing you see is a set of 3 buttons: download, CS10 course, and tutorials. And I'm about to click on tutorials. And what I find is 3 tutorials. So building tool blocks does the thing that I just talked about, which is making a for loop. And it takes, half an hour or an hour, whatever it is, to do it, going through it step by step by step. Listen higher order functions is about map and keep and combine and how to use those. And that's a big tutorial. And finally, recursion does the thing that we did earlier, which is the tree example. All 3 of those are available as a QuickTime movie that you can just watch, or as a Scratch project consisting of a bunch of slides. Not a BYOB project, a Scratch project. That's so people who haven't yet gotten the message can look at them and say, wow, this looks pretty neat. I'm going to download BYOB. So those things are resources for you. They're also resources for your students. There are going to be more of them next year. I'm taking a year off from teaching, and one of the things I'm going to do is catch up on making tutorials for this stuff. But I wanted to show you that those are out there. Okay, back to here. All right. What? What just happened? Oh. Okay, back to here. Okay. I think I'm finished talking about higher order functions. No?
Not with 10 minutes left. I would do
No.
acronym.
I'm gonna mention OOP. I'm not gonna show them, but I just want to mention what's the big new thing in BYOB 3.1 is we have a block called clone that makes a child of a sprite. So you have a sprite and it makes another sprite just like that one, but it's not just a copy of it. It actually shares data, like an object hierarchy. We have classes, variables, and instance variables. We can do all that with the sprites. So we don't yet have any curriculum at all that's based on that, on the OOP. So that's why I don't have to show it to you. But I want you to know it's there, and that's partly because you are going to run into somebody back home who thinks that the end-all and be-all of programming is OOP. And is going to say, you have to teach your children object-oriented programming. And the way to cope with that is to use sprites, because sprites are natural objects. They, there they are, they're visible. It's easy to see why you might want to have 20 identical sprites that behave almost the same way, You can have children of children of children. You can do all of that stuff in BYOB. So if that comes up, it's there. That's all I'm going to say about it. Okay, Dan wants me to show you acronym. So, sorry?
For my purposes,
Yeah.
since I don't have a programming background, so
Oh.
an object is something with properties?
Yeah, an object is something with an object is just like a data structure, like a list or something, except that it also has behaviors. Because sprites, they have properties like X position and so on, but they also have these scripts that you put in their scripting area, right? So sprites know how to do things. And if you make a child of a sprite, it knows how to do the same thing that the parents know how to do. Yeah, yeah. Okay, 10 minutes. Okay, here goes. Small stage. Get rid of the for loop. Back to map and so on. So here's my task. I want to take a phrase like the University of California at Berkeley, and I want to get its acronym, UCB. Okay? So here's what I'm going to do. First thing I'm going to do is I'm going to go to the operators menu. I'm going to scroll way down to the tools at the bottom. And the very last one is sentence to list. So I'm going to type in here, just as an example, the University of California at Berkeley. And I'm going to jiggle the screen a little. And then I'm going to click on this and show you the answer of that, which is a 6-element list. The University of California at and Berkeley. So it's a list with one word per element. And sentence to list is great because dealing with text strings is a pain in the butt. You write all these programs, and kids are accustomed to writing programs that go through looking for spaces over and over and over again. So if you turn it into a list, you now have a structured piece of data instead of an unstructured piece of data. And now I can use things like map to say, compute some function of every word in this sentence. Okay? So that's my first starting point, sentence to list. Now I want to make the acronym UCB. The first thing I have to do is get rid of the unimportant words, the and of and at. Okay, class, is that a map, a keep, or a combine? Keep, right? We want to get rid of some of the things and keep other things. So I'm going to grab a keep block.
So this is a wacky question, but is it upper and lowercase sensitive?
Not for equality comparisons. I don't think so. I'm pretty sure not. But
So it's going to grab a capital U, not a lowercase.
yeah, capital U. There is a ASCII to character code thing that you can use to check the case of letters. But I'm not going to do it that way, actually. I don't care about whether you type capital letters or not. Some words are important, and some words aren't important. And I want to keep the important words. Okay, so now I'm going to show you the abbreviation that you've all been tripping over, because it'll make life a lot easier, which is instead of having to grab the block all the time, I can take something like this contains block here, this contains block here, and I can drag it toward the keep to the gray hexagonal input slot. And as I drag, I get this white halo where I've been telling you to let go. But this time, don't let go. Keep dragging even closer. And then I get a gray border around the contains block, and now I let go. Okay, so keep item such that gray border thing, blah, blah, something contains something. We haven't filled in the spaces yet. Okay? I'm going to do that in a second. But this gray border means the same thing as the block. It means the input to keep is not the true or false that comes from some particular does this contain that question. It's the contains block itself that's the input to keep. So it's just like saying the block contains. And the gray border is a little easier. 5 minutes, says Dan. Okay, so I'm going to speed up. And what I'm going to do is I'm going to make a list with the list block of unimportant words. So like A and the of in at 2. And there's probably more that I should put, but this is good enough. So I'm going to say that as the first input to contains. So it does the, and then for the second input, I'm going to make that blank. So keep items such that this list contains that thing. Here, jiggle, jiggle. Of sentence to list, University of California, Berkeley. What's my answer going to be? Yeah, because what words am I going to keep? I'm going to keep the of at. That's not what I want. So I'm going to have to fix this bug. This is a bug in my program, which I'm going to fix by going to operators, finding a not operator. I'm going to grab this contains and put it inside the not. And I'm going to grab the not at the left and stick it in a gray border inside here. I'm going to wiggle the screen again. And now if I click on this, I should get University, California, Berkeley. Okay? 3 minutes, Dan says. Okay, do my best. Okay, so now I have the important words. Now, in order to make the acronym, what do I need from those words? The first letter, right? Okay, so I have a list of words. I want a list of first letters. Map, keep, or combine?
Map, keep, or combine. Mapping, every list, look it back on the first line.
Answer. It's actually a map. I'd give you real kids, I'd give you a long time to think about this. Some people say keep because it's just keep the first letter. But keep would keep words out of the list. So if I had University, California, Berkeley, I might end up with California, Berkeley, not with UCB. So I want to map the function operators, gray border, letter 1 of blank over what I got from keep. It's really important that you grab things by their left edge once you start getting these huge blocks. Otherwise, it gets messed up. So now, if I run this, I get the list U, C, B. But I don't want that. I want a text string. So how can I take this 3-element list, U, C, B, and get UCB from it? Map, keep, or combine? What? Yeah, combine. I want to squish them all together. So I'm going to take, what I want to combine with is this join block. So I'm going to have 2 blank spaces, which you need for an input to combine. And I'll catch you guys in TV land up in a moment. I'm going to grab a combine block and say, combine with join the items of, and now I'm going to put this map in there, grabbing it by its left edge and being careful to deposit it in the right place. Ah! Undelete. See you do that in Scratch.
0 minutes.
0 minutes. Okay, jiggle the screen. Okay, I'm going to run it. UCB. Ta-da. So now what I would really do, by the way, is make a block. I would say make a block operators, reporter, acronym, has an input phrase, and I would say report. And now I'm going to grab this thing and drag it in here. And instead of building in the University of California at Berkeley, I would just take phrase.